Hey everyone. So, if you've spent any time at all in software, you know that relational databases are, well, they're the bedrock, the solid foundation for just about everything. But what happens when that ground starts to shake? Today's apps are creating data at a scale that just demands a totally different kind of blueprint. So today, let's explore that new blueprint, NoSQL databases.
And that's a really fair question, right? Relational systems are powerful, they're reliable, we all know how they work. For decades, they were the go-to, the default choice. So, what changed? Why did the entire industry suddenly feel this urgent need for a completely new way of thinking about storing data?
Well, the answer really comes down to the unique pressures of modern applications. I mean, the internet didn't just connect a bunch of computers. It created this ecosystem of apps that operate on a scale and at a speed that was pretty much unimaginable just a couple of decades ago. And these new demands, they started to really push up against the built-in limits of that traditional relational model. And if you look at these demands, they really tell a story. We're not just talking about more data. We're talking about petabytes of it, way beyond what a single giant server can handle. We need systems that can scale up massively, almost instantly to handle a viral post or a Black Friday sale. And users, they expect 100% uptime, 24/7. No excuses. On top of that, with a global user base, your data has to be distributed all over the world for fast access. And you have to do all of this while constantly trying to keep hardware costs from exploding. It was basically the perfect storm, and it made it crystal clear that a new approach wasn't just a good idea, it was essential. Okay, so that is an intense list of demands. I mean, a traditional database would just completely buckle under that kind of pressure. So what's the answer? What's the solution to this modern data dilemma? You probably guessed it. The answer is NoSQL. And it's not just one single product, It's a whole new category of databases designed completely from the ground up to solve the exact problems of scale, availability, and flexibility that we just talked about. Let's break this down for a second. The word non-relational is a huge deal. It means we're finally moving away from those rigid tables and rows of SQL that we all know. And distributed, that's the real secret sauce. Instead of pouring all your money into one massive, crazy expensive server, NoSQL databases are built to run across clusters of regular, off-the-shelf hardware. And that distributed design is exactly what lets them handle enormous volumes of data and stay online, even if a few of those servers fail. So what do you get for adopting this new model? What are the big payoffs? Well, it really boils down to three core advantages that directly tackle the challenges we just saw. And here's the beautiful part, they all work together. First up, you have availability. Because your data is copied across multiple servers, the whole system stays up and running even if a server just dies. This naturally leads to the second advantage, fault tolerance. The system is just inherently resilient to failure. And all of that enables the real game changer, scalability. Need to handle more traffic? You don't go out and buy a bigger, more expensive server. You just add more cheap servers to the cluster. It's a fundamentally different way to grow. Okay, so we've got the what and the why. Now let's get into the how. What are the fundamental design principles that actually let NoSQL databases deliver on all these promises? Okay, three big things here. First, as the name NoSQL kind of suggests, they don't use traditional SQL. They have their own query languages that are tailored to their specific data models. Second, they are built for clusters. This isn't some add-on feature, it's baked into their DNA. But this third point, schemaless operation, this is what's truly liberating for developers. In the relational world, you have to define every single column and data type up front. Here, a collection can hold documents that have completely different fields and structures. This gives developers this incredible freedom to evolve their apps without needing these complex, painful database migrations every single time. And I totally get it. We're throwing around new terms like collections and documents, and it can definitely feel like you're learning a whole new language. So how does all of this map back to the familiar RDBMS concepts that you're so comfortable with? Let's connect the dots. Here's a pretty direct translation. What you call a table in the SQL world, that's basically a collection in NoSQL. A row or a record becomes a document. A column is now just a field or a simple key-value pair. And what about those really expensive joins? Well, in many NoSQL databases, you just embed the related data right inside a single document. This makes reading data incredibly fast because you're not trying to piece things together from all over the place. All right, let's dig a little deeper into that idea of scalability, because this is truly the architectural heart of what makes NoSQL so different and so powerful. So in the old RDBMS world, you typically scale up, or scale vertically. You buy a bigger, faster, and much more expensive server. But there's always a hard physical limit to how big that one machine can get. NoSQL is designed to scale out, or scale horizontally. You just distribute the data across a whole cluster of smaller, cheaper servers. When you need more capacity, you just add another server to the pool. It's an approach that's fundamentally more flexible, more cost-effective, and built for absolutely massive growth. And this isn't just some happy accident. This whole scale-out architecture isn't just an afterthought or a feature they bolted on. It is the core design philosophy. It's literally what these databases were built to do from the very first line of code.
All right, there's one last core idea we need to cover. It's a bit of a mouthful, but it's a really powerful concept. So, what on earth is polyglot persistence? Polyglot persistence is really just a fancy way of saying one size does not fit all. Think about it. A single application might have lots of different kinds of data. Maybe you've got user profiles, real-time shopping cart data, and then huge amounts of product logs. Instead of trying to force all of that into one type of database, you use the right tool for the right job. You might use a document database for the user profiles and maybe a key value store for session data, all inside the same application. It's all about picking the absolute best data store for each specific problem you're trying to solve. So if you're going to remember one thing from all of this, let it be this. NoSQL isn't just a different technology. It's a whole different philosophy. It's a way of thinking that's built for the incredible flexibility and massive scale that modern distributed applications demand. So I'll just leave you with this one thought. In an age where your users and your data are literally spread all across the planet, shouldn't your database be built to do the exact same thing? If this helped you connect the dots on NoSQL, do me a favor and hit that like button, and be sure to subscribe for more explainers that break down complex tech. Thanks so much for tuning in.